than what we just talked about because there's not a log on both sides where you can just set stuff equal to each other. So when your variable is inside the logarithm, see log base 9 of x. Over here in this equation, you have a log base 6, and then x is in there again. In this equation, you have log base 5, and x is inside there again. You need to get the x out of the logarithm, and the way to do that is to undo the logarithm, and logarithms and exponential functions are the things that undo each other. So yesterday, when we had like an exponent thing that we didn't know how to deal with, we used a log. Now when we have a log thing that we don't know how to deal with, we use an exponent. So we're going to rewrite this equation in exponential form. So which part of that equation will be the base? The 9. Okay, the 9 is the base on the exponent. It will also be the base for the logarithm. So when 9 is the base on the log. It will also be the base for the exponent. So 9 is my base, and then I want to write it to some power, and I want to know what it equals on the other side. What part of the exponential equation is the exponent? The x or the 3 over 2? The 3 over 2. The answer to a logarithm is the exponent, right? Remember, a logarithm's asking you what exponent do I put on this base to get this thing. So the 3 over 2 is actually the exponent. And the stuff inside of the logarithm, the x in this case, is what goes on the other side. Okay? So we rewrite this in exponential form, and it's basically done. X is by itself. Okay, we don't have to do anything else. We just need to calculate this if possible. So try to remember your exponent rules. If you want to think of this as two separate things, there's the part that's, there's the part that's making the fraction, and then that's to the third. What does a fraction exponent mean? We talked about it yesterday a little bit. We did them in Algebra 2, I promise. Yeah. Good. Something with a radical, and this is the index of the radical. So this one's going to be a square root. So this is really square root of 9, and we have 9 to the 1/2, and then that's supposed to be cubed. So this is actually something that's totally calculatable. I can figure this out. So the square root of 9 is 3. And then I'm going to cube that, which gives me 27. And then before I decide to keep that as my final answer, I want to look back at my equation and just make sure that when I plug 27 back in, the equation doesn't make any logs of negatives or zeros in the equation. Does 27 work? Yeah. Okay, it says log base 9 of 27. 27 is a positive number. I can take the logarithm of it. That's okay. Right? Any questions about part A? Right, what do we need to do in part B first? Yeah, we got to get rid of, see the 2 in front of the logarithm and then the -6 at the end? We can't do what we did in part A until we get the log alone on one side. So the first thing we want to do is add 6 to both sides of the equation. So it should then look like 2 log base 6 of x plus 1 equals 8. And then we want to divide by this 2 because it's not part of the logarithm either. So you want to get the log completely alone. So you'll have log base 6 of x plus 1 equals 4. Okay. So now that I got the log alone, what am I going to do? So now it looks a lot like part A. What did we do in part A? Right, we rewrote it in exponential. So which part of this equation will be the base for our exponential? 6. The base is still the base. Okay, so 6. Which part of the log equation represents the exponent? The 4. Okay? And then all that stuff that's inside those log parentheses goes on this other side here. Okay? I wouldn't expect you to know 6 to the 4th if that showed up, something that large showed up on a test. You could just leave it like that if you want. It's 1296. I'm not that smart. I put it in a calculator last period, and that's what it told me. Okay? So we get 1296 equals x plus 1. The x is almost alone, but not quite. We need to subtract 1. So we get that x is equal to 1,295. And then before we commit to that being our answer, just glance back at the original equation. If you plug 1,295 in where x is, does it create a positive number inside the logarithm? Then it's good. If you created a 0 or a negative, we'd have a problem. Okay, but because it makes a positive there, this is fine. Right, and then part C is a little more complicated because of the squared, but it's actually already set up. The log doesn't need to be isolated. It already is isolated. So somebody raise your hand and tell me how we would rewrite it based on what we've been discussing as the base, the exponent, stuff like that. Let's see, Sean. I know Sean knows. All right, Sean, go for it. Right, so base was 5. The base of the log is still the base. The answer to the log equation, so the thing that was opposite of the logarithm on the other side of the equation is your exponent, and the stuff inside of the logarithmic expression goes on the other side of the equation. Okay. So this is a quadratic, has x squared. Okay. However, it doesn't have any other term with x, so we can solve this quadratic a little simpler than we've done some of our others. We can just get the x squared alone and then like undo the squaring part of it, okay? So I'm going to rewrite 5 squared as 25. And then I'm going to add 144 to both sides, okay? If the 144 had an x with it, what would be different about my approach to solving this quadratic? So right now I'm trying to get x alone and just square root it. But if one of these other terms had an x with it, how would I do it differently? Okay. Good. Then we would try to get everything on the same side and either factor or use quadratic formula or something like that. Okay? So just be aware that we can't always square root, but because there was only an x squared here, we can in this instance. So if we add 144 to the other side, we get x squared equals 169, and then we will square root both sides. And then remember, we're actually getting 2 answers here. Okay? Because if I tell you I squared a number and I got 169, you don't know if I squared positive 13 or negative 13 because they both turn out the same way. So we have to consider both. Okay? And now before we commit to what is our solution, we just want to think about plugging it back in. If you plug positive 13 back into those parentheses where x is inside the logarithm, and you do x squared minus 144, is positive 13 an okay solution? Okay. What about if I plug in negative 13? It's still okay because negative 13 squared still turns into positive 169, which is more than 144. So when you subtract 144, you'll still have log of a positive number up there, which means it's a good solution as long as you did all your steps correctly. So both of these work, and we have 2 solutions in that instance. Okay? Are there any questions?